So now what I want to do is, I want to do off of this sheet, okay, off of this sheet, and I'm going to do something where they want you to design an experiment. It says, or figure out an experiment. It says, the question says, a student carries out an experiment to find the specific heat capacity of aluminum. He uses an electric heater and a thermometer inserted into separate holes in an aluminum block. And then they give the following data, okay? All right, it says the mass of aluminum is going to be 2 kilograms. Can you see that? Is that clear? Can you see that on the screen? Okay. It says the power equals 400, what is it, 420? 420 watts. The time is going to be 95 seconds. The initial temperature, what do you guys use? You guys use, I use T sub I, is that okay? Makes sense? Okay. 19.5. 19.5, sorry, degrees Celsius. And then T final equals 40.5 degrees Celsius. Okay, right away, let's write delta T as what? What's delta T?
21.
What is it?
21 degrees.
21 degrees Celsius, very good. 21 degrees Celsius. Okay, easy? Now, they want you to calculate a value of the specific heat capacity of aluminum. What's the equation that relates energy absorbed or released, mass, change in temperature, and specific heat capacity? Excellent. That's absolutely correct, Bosma. Well done. Okay. Excellent. So E equals M delta T C. Excellent. Well done. Okay. Good. So now, we're going to rearrange that right away for specific heat capacity before we even begin. And what's the rearranged equation? L for O's. That's absolutely correct. Well done. Excellent. So it'll be C equals E over, what did you say? M delta T. Excellent. Excellent. Well done. Okay, good. So now, we need to find out what E is. Shall we do E separately? What's E? Well, we know that the power is 420, correct? Yes? And we know that PT equals work, correct? I'm just rearranging. Do you remember that? PT equals work? Yes? You remember that? Because P equals work over T. So if I multiply this by T, I get work. Correct? Yes? So PT, right? So now, can we just do it? Is everything is in, have we analyzed the dimensions? Everything is good? Watts, joules, seconds, degrees Celsius, kilograms are there, everything's good, right? So now the equations will work as we want them to. We're good. Clear? Yes? Okay, good. So what's PT? Give me an answer. 420 times 95, what do we got? Somebody?
39,900.
No, don't go crazy. Tonight you're gonna be asleep, and you're gonna hear a knock on the door. Open up! This is the significant figure police. You're under arrest. Just don't go crazy with significant figures. 2 minimum, 3 maximum. Don't go crazy. Don't go nutty. Okay? You don't have to read everything off your calculator. Give me 2 significant figures. Look, 95, 2. That's what it is. So what is it? What do we got, girl?
14,000.
What is that?
14,000.
14,000?
14,000.
40,000. Is that all right? Mr. Significant Figures. Is that okay? You sure? Excellent. So 40,000. Okay. So the way you would do it, like officially, without using scientific notation, you write 40,000 like this. That's how you would do it. Isn't that weird? Did you know that? Yeah, that's a way of doing it. Otherwise, you'd say 4.0 times 10 to the fourth. Right? All right, either way. All right, so that's E, right? So E, can I erase some of this? Now, is this okay over here? Am I okay? My videographers, am I okay working here? Okay? So this is going to be what? C equals 40,000 over 2 times 21, right? So what's 40,000 divided by 42? So, what, 900 something? What do you got?
900.
What is it?
952.
952.
Yeah.
Yeah, don't go crazy. Don't go crazy. 950 is fine.
Okay.
Don't go nuts, okay? So C equals 950. But what are the unit labels? You got to put those in.
It was 92.38.
No, I didn't ask you for additional significant figures. You're losing your mind a little bit. That's okay though. I know you're excited to give me significant figures. What are the unit labels? What are the dimensions for? I don't know. That's it. Just shrug your shoulders. All this work we did, and you can't put the correct unit labels? IGCSE is going to say, thanks for playing. No credit. What are the unit labels for specific heat? Come on, guys. What are they? In this case, you don't know?
Okay.
I'll give you a quiz worth 1 billion points, and if you fail the quiz, you go back to 7th grade.
Joules per kilogram.
If you pass the test, I will give you a college diploma, university diploma. That's how important this is. What are the unit labels? Boswell.
Joules per kilogram.
What is it?
Joules per kilogram.
No, that's for latent heat.
Degrees Celsius.
Because you got degrees Celsius in here, so it's joules per
Degrees Celsius.
degrees Celsius and kilogram. You get it?
Yes, sir.
He just shrugged. He just shrugged. Like, do you like the weather today? Yeah. That's what it was like. Yeah. Ask me what do I like the weather today? Ask me. Go ahead. You ask me. Ask, do I like the weather today? Go ahead, ask me. Yeah. That's what he did. Can you imagine? All this work, and he doesn't know what the unit labels are. Man, I don't know. What are the unit labels? Okay, here we go. Are we done? Okay? Are you alright? Okay, you look very excited. Remember, you have a heart condition. Don't die on me because you're so excited, okay? Okay. All right.